Okay, so we're back to work on the flexible drive shaft coupling for the dyno. Basically, the way I'm going to start out this video is just kind of talk about what I picked out in terms of material and sizes to make these parts, kind of how I'm going to go about trying to make it. I guess I'll start out by talking about this part here, and what I decided was to rather than make this piece out of one large piece of steel and spend a lot of time turning this diameter out, which would be that'd be kind of a lot of material to remove. What I decided to try to do is like I said, rather than make it out of one big piece of steel, I have a couple of pieces of 5-inch diameter. This is just plain carbon steel. What I'm going to do, so we'll start out by talking about this one here. I'm going to make it out of this one, and this one is some leftovers from another project. What I'm going to do is I'm going to put a hole in the center of this, and then what I have over here, this is a cutoff from the main shaft from the dyno. So it's a 50 millimeter shaft. It's turned, ground, and polished. So what that means is that this piece is going to be pretty straight, and the diameter of it is going to be pretty precise. So what I'm going to do is, like I said, rather than make this piece out of one large piece of metal, I'm going to put a hole in this, and then I'm going to have to bore that hole to a very specific diameter. And what I'm going to do is I'm going to use this shaft here, install it in here with a press fit. Now, one of the downsides that I didn't really like when I bought this shaft for the dyno, but it actually turned out to be something that I used later, is that it has a keyway machined in it, which for what I'm doing here is not ideal, but I think it's probably going to be okay. It should be okay. So, and I guess the next part is this piece here. And I just, like I said, I already had this around from a previous projects, but I bought this piece here, and it's basically the same material, only it's a 1-inch thick. But the difference between this part and this part is that rather than the shaft going on here with a press fit, this is going to go on to here with with some clearance so that it can spin freely on there. It needs to be able to do that in order for this this coupler to do its job. Okay, so because when it comes to an interference fit, especially when you're going from steel to steel, the interference, in my opinion, is going to be pretty small. So maybe like half a thousandths to maybe a thousandth. It's kind of what I was looking for. So the way I'm going to measure that is with my, you know, you've seen me use this before. It's one of those entry-level dial bore gauges. And what I did was I took the 50 millimeter turn, ground, and polish shaft, and so I set up my micrometer on here, so as if I was measuring this piece, and then I locked it into place using that. So basically what I did is, and then I put that in there like that and zeroed the indicator on here, so basically it turns this thing into basically a comparator. So it looks kind of to me like we're in about maybe about a thousandths. Maybe about a thousandths of interference there, maybe a little bit more. Alright, so I got it all turned around back on there. I'm indicating on the machine side of that part. I got it down maybe, I'd say I got that less than half a thousandths, which for me is pretty good. So let me face this off, get that done, chamfer these two, and then the lathe work on this part will be done. But now what we need to do is we need to put these bolt patterns. Into these parts. The way I did that was I basically took the solid models, or the 3D models that I had in Fusion for here, and then I just made all those holes there the same size. And I gave it a register here. So, and I made a different tool for each part. So A and B and B. The only difference between the parts is that the register diameter. That feature there is a little bit smaller than it is on this part. So the way I'm going to do that is the way it works. And I've done this 2 or 3 times before, and it seems to work okay. So it's not perfect, but it seems to work pretty well. And what I do is I pick out a transfer punch, and then I find out what the diameter of it is, and then I make it so that the transfer punch fits into there nice and snug. And I usually have to use a drill to finish the size of it. But the idea is that it goes on there like that. And then I put a hose clamp around it. So the hose clamp is holding onto both this piece and the workpiece. And then I just go around with the transfer punch and transfer those punch marks into the workpiece. Then we can take that part over to the mill and then start putting these features in. And you can see the transfer the part, so I'm going to go with the I did these 4 features here and bolted it on there just to see if I'm close and see how those bolt patterns between here and here lined up. Kind of what I'm seeing here. And the other thing I wanted to do real quick was throw an indicator on there and see how much run out I had so far. And it's 25 thousandths, which of course is way too much. But that's because this part's registering on this part via the bolt pattern, which is no way to align 2 parts. Once we get that shaft in there, that should line this part up with this part a lot better. And I put the indicator on this part of it, and I was within like 1 to 2 thousandths, which is okay with me. And then the other thing I would say is that it's possible that I may need to go in there with maybe a die grinder or something and add a little bit more clearance between the bolt and this part, but that's okay with me. Now that we've got that done, we know that this bolt pattern's pretty darn close. We can go in and start doing the other 6 features for this. Okay, so I'm getting kind of close to the end of this part. I got all these features put in there, and now what I need to do is I've drilled this for these 3 here for a 12 millimeter by 1.5 tap. So let me get to work on that, and we'll go from there. Okay, so I got these 3 holes here threaded. And I tapped that with the 12 millimeter by 1.5, and for whatever reason, I ordered bolts that I thought were 12 millimeter by 1.5, but they're 12 millimeter by 1.25. So I'm gonna have to get some different bolts. Anyway, we're getting kind of close on this part. I still got to do that part, and I think the next thing we'll do is figure out how long a piece of this I need, and cut it to length and start fitting it into there and getting it pressed in. Okay, so I'm kind of running out of time this week, and what I'm just going to do, though, to speed things along is I'm just going to put this, rather than film the whole thing, I'm just going to put this in the lathe here real quick, switched over to the 3-jaw, I'm going to face it off on the ends and chamfer the edges, so let me do that. Okay, so we got that piece all faced off, chamfered on both ends, looks like it's going to be okay, well, let's hope it's okay. 20-ton shot press here, so let's see if we can get this thing pressed into place there. Okay, so I have that back part sticking out about 1/8 of an inch, which is about where I wanted it. So let's go over to the bench and test fit this, see how we did. Alright, so let's just do a quick test fit here, see where we are so far. Okay, that lines up on there, and then this goes on to here. Alright, so far so good. That'll, once I put these, ouch. Once I put the holes for that into place there, that'll sit in another, I don't know, 1/8 of an inch. And that'll give this shaft ended up coming out about 100 thousandths shorter than what I wanted, but I think that's going to be okay. And if I ever need to change it, I can. Alright, so far that seems alright, and like I said, that'll slide in a little bit further, and then that'll move in a little bit further there, and it gives me the roughly 1/8 of an inch or so, or 150 thousandths of a recess in here that I need for the drive shaft to register onto this part. Well, anyway, some of this stuff took me a little bit longer to make than I thought it was going to, and some of that was because I had to run to get parts, and I need to reorder some fasteners and everything like that, so this part's not going to get done this week. But I got pretty far. I'm pretty happy with that. So basically what I'll do off camera is basically make this part here, which is it's going to be very similar to the operations that I did on this, so you're not going to miss out on any. You're not going to miss anything by not seeing me make this part. But that'll be the next thing I do, but I don't have time enough to do that this week. At any rate, I guess that's about all I got for you this week, and I guess I'll see you next time.